Hi guys, and welcome back to winter school. I hope that you're all having an awesome time. When I pass back to ET, please don't get a fright because ET has been replaced with Tamlin, and I'm sure ET will be back a little bit later. Burntley is with us, and she's sitting in studio today, and she is working with Tamlin and working with the teachers, and it's awesome. She just told me that her name actually means beautiful, right?
That is in Sotho.
So guys, let me know, what do your names mean? I know that Indiana, I'm searching for Tamlin in Indiana, but I'm not quite sure if we actually have a meaning.
Not going to win.
Yeah. So chat to us on facebook.com/learnextra. Also chat to me on Twitter @learnextra, and keep watching for those competition rules and how to win it, and we will be posting it again on the page because I don't want to waste any more time and I want to send the lesson straight to Tamlin. Tamlin, take it away.
Thanks, Indy. Thanks. Welcome, Mindsetters. Right, what we're going to have a look at now is a few examples involving circles and tangents, okay? Still as part of the analytical geometry section, so very much sort of part of what we've already had a look at today. Okay, before we get going, let's just take a look at a few basic things. First of all, when we are working with the equation of a circle where the center of your circle has been moved off the origin, okay? So both of these circles, if you have the circle M and the circle center P, both of them have been moved off the origin, okay? And when we're looking at the standard equation of those circles, we're working with the standard equation of x minus a squared plus y minus b squared, and that's going to be equal to your radius squared, okay? With that standard formula, please remember that the negative a and the negative b form the coordinates of your circle center, okay? And because both of them have got a negative in front of it, when we take those coordinates out to make it into a coordinate point for your circle center, the signs must change, okay? So bearing that in mind, let's have a look at what they've given us over here. We've been told that x plus 2 squared plus y minus 1 squared equals r squared, and that's the equation for the circle that has the center M. Right, so we're looking at the smaller of the two circles over there. Straight away, because I've been given this equation, because I've got x plus 2 and I've got y minus 1, we are straight away able to see what the coordinates of my circle center is, okay? If I've got plus 2, that means that the x coordinate of my circle center is going to be minus 2. And if I've got minus 1, the y coordinate of my circle center is going to be plus 1, okay? Right, now we know that. They've told us that our point S, which is the point where the two circles touch each other, the points of contact between the tangent and the circles, that is the point of 1 and negative 2, and then finally P, which no doubt we're going to have to work out later, the values of A and B. Okay, let's have a look at our first question over here. They are asking us to write down the coordinates of M and the radius of the circle center. Okay, so do you guys agree that in fact we have started off answering that question already, because M, we got straight from the equation, is the coordinates of negative 2 and 1. Okay, so first part of the question answered, okay? M is the coordinates of negative 2 and 1. And now they want the radius. They want the distance of the radius. Now, as we sit at the moment, I know what M is. I know the coordinates of M. And I know the coordinates of S. Okay? So to work out the distance of that radius, what I'm going to use is my distance formula. Okay? And we are going to work out the distance from M to S. Point S was the coordinates of 1 and negative 2. Right, so distance formula. My distance from M to S squared is going to be equal to x1 minus x2 squared plus y1 minus y2 squared. At this point over here, please just take an extra moment to be careful that you're substituting the right value into the right place. You've got lots of subbing to happen here, so you've just got to be extra careful with that, okay? Right, x1, so ms squared is going to be negative 2 minus x2, which is positive 1 squared. And I've got y1, which is 1, minus negative 2 squared. Okay, Bootle, happy with that so far?
Yes, just want a quick question quickly. Couldn't you just take that point and sub it in back to your formula to get the r squared? So you take the is that S?
This point over
Yeah,
here.
1
in
and
fact,
negative 2
yes,
and then put
you
it back
could.
in the formula.
Yes, you can.
Oh, okay,
Okay.
that's
While
fine.
we're at it, though, we're going to carry on with this over here.
Okay.
We've got ms squared. I've got, that's going to be negative 3 squared. I have got 1 plus 2, which is going to be positive 3 squared. That's going to give us 9 plus 9. That gives us 18. Don't forget that what we're sitting with over here is ms squared. Okay? So to get rid of my squared, we are going to square root it. So therefore, our ms is going to be equal to the square root of 18. Now, just to simplify that, 18 can be written as 9 times 2. Okay? 9 is a perfect square. 2 is not. So what I'm going to do is I'm going to take the square root of 9, which is 3, and we're going to put that outside the third. But 2 is going to stay inside the third. Right, so what we've established is that our distance from M to S, our radius, is going to be 3 root 2. Okay, so that's what we've got over here. 3 root 2. Okay, right, that's the first part of the question. Let's look at the next part. Okay. Okay. The next part of the question is now asking us to determine the equation of the tangent of RS in the form y equals mx plus c. Straight line graph, we're working with a normal straight line graph over here. The first thing that we must know about a tangent and a radius is that they are perpendicular to each other, okay? That's going to be crucial to know because what we're going to use is we're obviously going to, we know what m is, we know what s is. M was, and I have to remember this.
We square root 2.
M was negative 1 and, no, I need to remember. Sorry guys, give me one seckie. It was negative 2 and 1, right? Negative 2 and 1. Negative 2 and 1. And point S is 1 and negative 2. So, in order to work out the gradients from point R to from R to S, the gradients over there, what we have at our disposal is that we can work out the gradient from M to S, and because your gradient and your tangent are perpendicular, we're then going to be able to flip it over and change the sign. Okay. Gradient from M to S, if we take our gradients from M to S, okay, we're taking our y2 minus our y1, and we're going to put it over x2 minus x1. Okay, so y2, which let's say is negative 2, minus y1, which is 1, over x2, which is 1, minus that, which is going to be negative 2. Right, so we are sitting with negative 3 over positive 3. That's giving us a gradient of negative 1. So if our gradient from M to S is negative 1, remember that to work out the perpendicular gradient, what we do is we invert our gradient and we change the sign, okay? If you're working with a whole number like positive 1, if you were to invert the fraction of 1 over 1, it's going to obviously just stay 1 over 1. And instead of having a instead of having a negative 1 as your gradient, we're now going to have positive 1. So my gradient from R to S is now positive 1, okay? So straight away we can say that we've got y equals 1x plus c, and now we need to find the distance of c. If I look at point S is sitting on your line, and if you are ever sitting with a point on a line, in order to find a missing value, substitute that point into your equation. So if I've got 1 and negative 2, I'm going to substitute x with 1 and y with negative 2. And that is going to help me find the value for c. Okay? So we are going to have, I've got negative 2. We've got negative 2, which is equal to 1 plus c. And when I move 1 over, we're going to get negative 3 being equal to c. So therefore, the equation of our tangent is y is equal to 1x minus 3. 1 positive gradient minus 3, that looks about right, that we should have our y-intercept over there. So I'm happy to say that that all fits. It works nicely. Okay, all right. Next part of it. Okay. Now what we've done is we have found our equation of our tangent. We've done all of that. The next thing they're asking us to do is the circles having centers P and M touch externally at point S. SR is a tangent to both of the circles. So if MS, if the ratio of MS to MP is in the ratio of 1 to 3, determine the coordinates of A and B of point P. Okay, right. This question is going to involve a bit of work. Okay. We're looking for point A and point B. Okay, so immediately that should be saying to us we're looking for the value of two different variables. Somewhere along the line here, we're going to use a simultaneous equation. Okay, so we need to see what are we going to make our two equations up out of. Okay, they told us that the ratio of length MS to MP is in the ratio of 1 to 3, okay? When we're working with ratios, instead of writing it as a ratio like that, what we can do with it is we can write it as a fraction. So I can say MS over MP is equal to 1 over 3, okay? Now what we can do there is that if I were to cross multiply it, we could then say that therefore 3 times MS is equal to 1 of MP. Okay, so 3 times the distance of your MS is going to be equal to the distance of your MP. Okay, right, so let's, I hope you guys all agree we're going to use a little bit of distance formula here. There's a bit of time saved, however, because we already know what the distance from M to S was. We worked that out in the very beginning. We worked it out as the radius, okay? And we said that 3 root 2 was the distance from M to S, okay? What we need to do is work out the distance from M to P, and that's going to involve a bit more working out. M was negative 2 and 1, P is A and B. So let's just get ourselves organized here. M was the point negative 2 and 1, P is the point A and B. The distance from M to S, we said, was 3 root 2. Okay, so let's substitute that in here. When we're working with distance formula, remember that we don't just say MS, we say MS squared and MP squared. So therefore, what I'm going to have to do is I'm going to have to square both of those sides over there to make it fit with our distance formula. So therefore, what I have got is 9 MS squared is going to be equal to MP squared. Okay. Now we're going to say 9 multiplied by, my distance from M to S was 3 root 2. So we're going to say 3 root 2 squared is equal to, now we're going to take the distance from M to P using our distance formula. So we're going to have, let's just quickly write it for safety's sake, x1 minus x2 squared plus y1 minus y2 squared. And when we sub that all in, first of all, let's just do a bit of working out over here. If I take 3 squared, that's going to be 9. And if I take the square root of 2 squared, remember a square and a square root cancel each other out, so we are left with just 2. On this side over here, let's get our coordinate points. Right, the x-coordinate of M is negative 2. The x-coordinate of P is A, and we are going to square that. The y-coordinate of M is 1 minus the y-coordinate of P, which is B, and that's going to be squared. Okay. And we are going to have to just tidy that up one more step. 9 times 9 is going to be 81. 81 times 2, we have got 162. Am I right? 162. And okay, now we're sitting with this side over here where I've got 2 brackets which are both being squared. You can square them out, okay? But a small word of advice is that maybe just for now, don't, okay? Because by squaring it out, you're really making it quite long and you're making it quite complicated. And you'll find that sometimes that's going to make your life a little bit more difficult. So just for now, I am going to keep that as negative 2 minus a squared. And I'm going to keep that as 1 minus b squared. And this is what I'm going to call equation 1. All of that work just for equation 1, okay? Okay, so we've got equation 1. Now we need to look carefully at our diagram and see how can I formulate equation 2, okay? We need to involve this point, all right? That's definitely got to be involved over there, and we've got to decide what can we use. if I look at the radius from point P to point S, okay, whatever the gradient of from point P to point S is, it would be perpendicular to my tangent, hey? And we've already worked out that the gradient of our tangent was 1, all right? So what I'm going to do is I'm going to make my equation 2 out of that theory over there, that the gradient and the radius and the tangent are perpendicular, all right? So this is where equation 2 is going to come from. The gradient from P to S is perpendicular to the gradient from R to S. The gradient from P to S multiplied by the gradient from R to S, which is something that E.T. was talking about just now, is equal to -1. Okay, when the two perpendicular gradients are multiplied, they give us -1. Okay, point P, remember, was the coordinates of A and B. Point S's coordinates, we're just writing them here so we don't make any silly mistakes, is going to be 1 and -2. Okay, and there's no reason for us to go and rework out the gradient from R to S. We already knew that that's 1. Okay, so we've already got that there. So when I take my y2 minus my y1 over x2 minus x1, multiplied by, that's going to be the gradient from P to S, multiplied by the gradient from R to S, which we already know is 1, and we've said that that's all got to be equal to -1. Okay, subbing in y2 minus y1, so I've got b minus -2 is going to become +2, and I've got x2 minus x1. We're multiplying it by 1. Do you agree with me at this point? If we're timesing it by 1, we can just drop that because anything multiplied by 1 is itself, and it will be equal to -1. Okay, and if we take our denominator down here and we multiply it up on the other side, b plus 2 is equal to -1 multiplied by a minus 1. Finally, we've got b plus 2 is equal to -a plus 1. And if I get b on its own, I've got b is equal to -a plus 1 minus 2, which is going to give us -1.
Yeah.
That's our working out. That's equation 2. Okay, bear with me for a second. I'm going to go back over that for 1 second, just so you guys are completely clear on what it is that I've just done. Okay, there's a lot of complicated working out here.
Well, maybe what we can do is we can go to an ad break and we can tackle it after the ad break.
We need one.
Yeah,
Yeah.
I can see. I can just see. Buntle has been watching the whole time. You know, she hasn't taken her eyes off the screen. I was even trying to send her like subliminal messages. So what we're going to do, guys, I see that the page is quite quiet, and so is Twitter. But that's okay because I know that all the mindsetters have their heads down and they are working hard because these are tough things to tackle and tough things to understand. But guys, you can do it. And on that note, please during the break post questions onto the page. I see you all answering the challenge question, which is great because you win prizes. But if there is anything you aren't understanding, please let us know on the page so we can go through it. There's no such thing as a silly question. Only the question that's asked after the exam. See you now after the break.